Alright, this video is going to try and link the Karnaugh map with the Venn diagram and understand, why this column adds up to the probability of B, why this column adds up to the probability of B prime, why this row adds up to the probability of A, and why this row adds up to the probability of A prime. Okay. So we can set up this Karnaugh map with B and not B in the columns, and then A and not A in the rows. And this intersection is the probability of A and B. This intersection is probability of A and not B. And then this one and this one add up to the probability of A. So let's see why that's the case. Alright, so it says the probability of A and B, which that turns out to be the intersection, doesn't it? Probability of A and B is this, the intersection, plus the probability of A and not B. So the intersection between A and not B, well, let's colour in not B. Everything that's not B is all of this. Alright, and what's the intersection of those two? It is this amount. And what does that add up to in total? Just the probability of A. Yeah, the probability of A. Okay, let's do one more. Probability of A and not B plus the probability of not A and B adds up to the probability of B. And that was basically just the same thing, isn't it? The intersection is this one, and not A and B, so everything that's not A, and B. Where's the intersection? Intersection is here. So the total amount that we get when we add this one and this one together is just the probability of B. Okay. So we should be able to link the Venn diagram with the Karnaugh map, and then we should be able to answer these types of problems with Venn diagrams or Karnaugh maps. So let's try and use the Karnaugh map, and we might have to use some of the rules that we know as well. So probability of C or D is 0.85. Okay, that doesn't help us too much with the Karnaugh map, but let's just continue and see what else we've got. Probability of C is 0.45, and probability of not D is 0.37. Okay, so let's just set up our Karnaugh map. Alright, set up our Karnaugh map and try and link it to the one above here. So I have C, not C, D, not D. Alright. And now I'm going to color code the information I've got that will help us. So probability of C is here. And if I'm looking at the above kind of map thing here, then this one is going to be the probability of C. So this plus this is the probability of C. So that is 0.45. Okay. Probability of not D is 0.37, and probability of not D is going to be this plus this, gives me 0.37. And then I know probability of D is 1 minus 0.37, which means 0.63. So that means this one has to be 0.63. That's the 1. And probability of not C is going to be 1 minus 0.45, so it's going to be 0.55. Alright, now I think I'm going to have to use some rules. Probability of C or D plus probability of C plus probability of D minus probability of C and D. So 0.85 is 0.45 plus 0.63 minus probability of C and D. Minus probability of C and D. So if I move it across, I get probability of C and D is 0.45 plus 0.63 minus 0.85. 0.45 plus 0.63 minus 0.85. So that's going to be 0.23. That's C and D, so this one is 0.23. That one means that this one has to be 0.4. And now 0.23 plus something is going to be 0.45, so 0.22. And 0.4 plus 0.5, 0.4 plus something is going to be 0.55, so 0.15. And now, can I ask all of the questions? A, probably D we've got, yep, 0.45. B, probably C and D, 0.23, we worked that out with the rule. C, probably C and not D. C and not D. C and not D is this one. It's going to be 0.22. The probability of not C or not D. Probability of not C or probability of not D. So let's try and color code. Probability of not C is this one plus this one. So this is the probability of not C, 0.55. Or the probability of not D. Probability of not D is this one, right, which is 0.37. But let's be a little bit more specific. 0.55, the probability of not C is this plus this. Okay? And the probability of not D is this plus this. Alright, so we've double counted this amount. So I need 0.4 plus 0.22 plus the 0.15 to give me the one I want, 0.4 plus 0.22 plus 0.15 is going to give me 0.77. Okay. Now you can do it like that with the Karnaugh maps, as long as you get the Karnaugh map correct. I did it with rules and Venn diagrams, okay? So my color code, because I find it easy and nice to visualize it. C and D, the events, so here's my Venn diagram. C and D is this one, plus probably a C, this one, probably a D. I'll color code that from here. So this is just the law, the addition rule. And then I'm just using just complement, completes the whole, 1 minus the probability of this guy, has to give me the probability of D. And so from that I've answered A, and probably of C and D I get by just substituting in here. Or rearranging, sorry, the addition rule. And then I'm after the probability of C and not D. Okay, C and not D. So what I did, right, was I drew my Venn diagram, and then I've got that the probability of C and D from my previous part is 0.23. So I put that in here, 0.23. And I've got that my probability of C is 0.45, so this one has to be 0.22. That one gives me probability of C as 0.45. And then I have my probability of D here is 0.63. So 0.23 plus something has to give me 0.63, so this one has to be 0.4. And then I know that probabilities have to add up to 1, so 1 minus 0.22 minus 0.23 minus 0.4 turns out to be 0.15, so it goes in the outside. Alright. And then I've got a Venn diagram, and I can color code what I want, so probability of C and not D. So if I color code probability of C and not D, so the intersection, so C is here, alright, and not D, I'm going to color code not D, all of this. Now where's the intersection? Where do they overlap? They overlap at 0.22. Right. And then I did the same thing for the other one. So I drew my Venn diagram again, so you get 0.23, 0.22, 0.4, 0.15, and the probability of not C, or probably not D. So probably not C. Color coded as here. Alright. And then I color coded D. Everything that's not D. Alright, so that or that. So everything that is in both, right? And that's 0.23, 0.22 plus 0.4 plus 0.15, which is 0.77.